Hello guys, you're welcome to my channel. Today we are going to continue from where we stopped. That is the concept of trigonometry. Remember, we are still on the pre-calculus class and today we are starting with multiple angle formulae. If you're watching for the first time and you're yet to subscribe to this channel, kindly do that now. You are the only one that can assist me to reach 100,000 subscribers. Kindly like this video and drop your positive comments. That will encourage me to produce more useful video. Thank you. Multiple angle formulae. I'm going to start by looking at that of sine. If I have sine 3a, how can I expand this? I can write this as sine of 2a plus a. In our previous class, you can find the link in the description box below. We expand sine a plus b. The same way we expand sine a plus b is the same way we are going to do this. So I will have that sine of 2a plus a equal sine of 2a cos of a plus cos of 2a sine of a, like that. Now, because what I want to expand is sine 3a, I will need to express all my answer in form of sine. That is, I don't want any of these cos to show face. So, I will have that sine of 3a would become, instead of sine 2a, I will write it as 2 sine a cos a. Remember, we have cos a here before. Then plus, instead of what? Cos 2a, I can write cos 2a in terms of sine, and that will be 1 minus 2 sine square a, then multiply by sine a, like that. So, sine of 3a will then become, if this should multiply this, I will have 2 sine a cos square a. Plus, use this sign to open this bracket. We are going to have sine a minus 2 sine cube a. So the only cos I'm having now is that of this. And I can write cos square a as 1 minus sine square a. So sine of 3a would then become 2 sine a in bracket 1 minus sine square a, like this, plus sine a minus 2 sine cube a. Are we together? Okay guys, if you are with me and you are getting this, let's quickly expand this so that we can arrive at our final answer. So we have this to be 2 sine a, and they should become minus 2 sine cube a plus sine a minus 2 sine cube a, like that. That shows that this and this we can add them together, and this we can add them together. Hence, we have that sine of 3a will give us 3 sine a minus 4 sine cube a. So this gives us the expansion for sine 3a. As simple as this. So let's look at what cos 3a would be. Okay guys, so cos 3a, this will give us the same thing as cos 2a plus a, just like this. Okay, so cos of 2a plus a is the same thing as we are going to expand cos a plus b. So this will give us cos 2a cos A minus sine 2A sine A, like that. So cos of 3A will then equal, we have to express everything in terms of cos. I can write this cos 2A as 2 cos squared A minus 1 multiplied by cos A. The minus, instead of sine 2A, I can write it as 1 minus, okay, sorry. Instead of sine 2A, I can write it as 2 sine A cos A, then sine A, like that. Okay guys, let's be energetic now. Okay, so we are going to have that cos 3A equal this multiplied by this. We are going to have 2 cos cube A minus cos A, then this multiplied by this. We are going to have minus 2 sine square A cos A, like that. Okay, so cos 3A will then equal 2 cos cube A minus cos A, the minus 2, this sine square A, I can write it as 1 minus what? 1 minus cos square A, then multiply by cos A, like that. So cos 3A will then become 2 cos cube A minus cos A, then minus 2 cos A, then plus 2 cos cube A, like that. So we can collect the like term now. We are going to have that cos 3A equal this plus this. That will give us 4 cos cube A, and this plus this will give us minus 3 cos A. And this gives us the expansion for cos 3A. So let's quickly look at that of tan and see what we are going to have in result. Okay, so if I have tan of 3A, tan of 3A is the same thing as tan 2A plus A, like this. So this should be tan of 2A plus A. It will give us tan 2A plus tan A divided by 1 minus tan 2A tan A, like this. So tan 3A will then become, tan 2A can be written as 2 tan square A divided by 1 minus tan square A plus tan A, all divided by 1 minus tan 2A, same thing as saying 2, this is supposed to be 2 tan A, so this will be 2 tan A divided by 1 minus tan square A, then multiply by tan A, like that. So tan of 3A will then become, this now will be 2 tan A plus tan A into 1 minus tan square A, like this, divided by, forget about this, don't put this here because this and this will later cancel, so forget about it. So we're going to have 1 minus tan square A, then this times this will become minus 2 tan square A, and that is what we are going to have now. So permit me to clean this. So we then have that tan 3A is equal to 2 tan A plus, this times this will become tan A, and this time this will become minus tan cube A, divided by this and this, we can add them together. We have 1 minus 3 tan square A, like that. So, in a nutshell, the expansion of tan 3A will become 3 tan A minus tan cube A divided by 1 minus 3 tan square A. So, here is the expansion for tan 3A. Okay guys, we've seen how to expand sine 3A, cos 3A, and tan 3A. You can as well lay your hand on how to expand sine 4A, cos 4A, and tan 4A. You can as well work on every other multiple angles like 5A, 7A, 8A, and so on like that. So guys, let's look at the next thing under this trigonometry, and that will be the reduction formula. Okay, so we have to look at the reduction formula. So we are done with multiple angle formulae. So let's quickly look at reduction formula. Reduction formula. Now, the reduction formula is very, very useful both in algebraic and also in calculus. But remember, this class is basically because of calculus. So please master this very well. And now I'm going to start by looking at the reduction formula for sine square x. Now remember, if I have cos 2x, I can express it as saying 1 minus 2 sine square x, like this. So I want to make sine square x this formula, so I will have 2 sine square x to equal 1 minus cos 2x, like this. So sine square x is 1 minus cos 2x divided by 2. And this would be our reduction formula for sine square x. So when you reduce sine square x, it's going to become 1 minus cos 2x over 2. This can also be called the half range formula. Are we together? Like I explained in our previous class. So if I want to look for that of cos, I'll still continue from here. I'll say cos of 2x is the same thing as saying 2 cos squared x minus 1. So let's make cos squared the subject of the formula. So we have 2 cos squared x to equal 1 plus cos 2x. So cos squared x is 1 plus cos 2x divided by 2. So this is the reduction formula for cos. Please let's take note of that very well. So let's quickly look for the reduction formula for tan. So if I have tan square x, how can I reduce it? So let's just see. Tan square x is sine square x divided by cos square x. So our sine square x is this. So we have that tan square x equal 1 minus cos 2x over 2 divided by cos square x 1 plus cos 2x over 2. So these 2 and these 2 can cancel out. So I then have that tan square x is 1 minus cos 2x divided by 1 plus cos 2x. And this should be the reduction formula for tan. Are we making sense, guys? If yes, let's look at the next thing here. Now we've seen what the reduction formula for sine, for cos, and for tan. Let's take a look at one question under this before we go on. Okay, let's take for instance that we are given the question that reduce 4 sine square x cos square x. We are asked to reduce what? 4 sine square x cos square x. How can we do that? Okay, very simple. All we just need to do is to know what? The reduction formula for cos and sine. So, instead of having sine square here, we'll replace it with the reduction formula, and that will be 1 minus cos 2x all over what? All over 2. Then multiply by cos square x, which is 1 plus cos 2x all over 2, like this. So if this is what we have that 4 sine square x cos square x is equal to 4 into bracket 2 times 2, that will give us what? 4. 1 times 1, that is 1, and 1 times this will give us what? Cos 2x, and this times this will give us minus cos 2x, then this times this will give us minus cos square 2x, like this. So this 4 can take care of this 4. So we then have that 4 sine square x cos square x is equal to this, and this would also take care of each other. I would then have 1 minus cos square 2x. But I can stop my answer here. Why? Because we are asked to reduce what? The given question. And if you look at cos here, we are still having it to be what? To be square. So it's not yet reduced. So we need to reduce this. So I can now say 1 minus, if I'm going to reduce this, I will assume that I'm dealing with cos square x. If I'm dealing with cos square x, I will have it to be 1 plus cos 2x all over 2. But if you look at it now, I'm having 2x here. If I double this 2x, it's going to become what? 4x. So this should become what? 1 minus into bracket 1 plus cos 4x all over 2, like this. Are we together? So if I have 4 sine square x cos square x, so these two multiply this, I have to minus 1 minus cos 4x all over 2. So we continue from here. So if you look at this now, this will give us what? 1. So I'll be having what? 1 minus cos 4x all over 2. So in general, we say 4 sine square x cos square x is equal to 1 minus cos 4x all over 2. So that is what we reduce it to. So we can then what? Carry on whatever operation that it asks us to carry out. Like for instance, if it is integration, after we have reduced to this level, then we can now what? Integrate. So at times, it might be a bit complex. So let me just make it a bit complex while you try that yourself, and let me know what your answer will be in the comment section below. Now, if you look at it now, it is what? Even. Let me make it 1 odd and 1 even and see what you are going to end up with. So let's say I have, okay, let me just say I have 8 sine 4x cos cube x. So reduce this and let's see what your answer will be in the comment section below. So I believe we are making sense. So let's go to the last section of the class, and that is the factor formulae. Remember, every bit of this lecture from day 1 to this lecture, which we are calling the concluding lecture, is going to be useful for you in calculus. So please take it serious and master it. Let it become part of you. Thank you. Now let's see the factor formula. The factor formula. Now guys, when you talk about the factors formula, we have to derive it. Let's see how it goes. If I have cos of A plus B, my result is going to be cos A cos B minus sine A sine B, like this. And if I have cos A minus B, my result will be cos A cos B plus, this will be plus sine A sine B. If I call this equation 1 and I call this equation 2. If I had equation 1 and 2 together, I will have cos of A plus B plus cos of A minus B equal 2 cos A cos B. So I'll call this equation 3. So if I have equation 3 like that, and instead of adding these two equations together, what if I take the difference? That is, if I have cos of A plus B minus cos of A minus B. This will give us minus what? Minus 2 sine A sine B. And this will be our fourth equation. That is, if I take equation 2 away from what? Equation 1, I'm going to end up having what? Negative 2 sine A sine B. Okay? What if I now have sine of A plus B? My result is going to become sine A cos B plus cos A sine B. Let's call this equation 5. And if I have sine A minus B, this will become what? Sine A cos B minus what? Cos A sine B. Let's call this equation 6. Now, if I had equation 5 and 6 together, I will have that sine A plus B plus sine A minus B equal, if I had these two together, this and this will cancel. So I'll be having 2 sine A cos B. And this will be our 7th equation. Instead of adding these two equations, if I subtract equation 6 from 5, I will then have what? Sine A plus B minus sine A minus B, and that will give us what? So if I take the difference between this and this, what am I going to have? This will become sine A cos B, or cancel out this. Then this will become what? Plus. So I'm going to be having 2 cos A sine B. And this is our equation 8. Okay, guys. I believe we can see what we have here. Now, the main focus of this class are these following what? Equation. This particular one, equation star, 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 and the last two equations where we have equation star, 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 and star, star, star. So that's our focus. So if I clean this one like this, and I make what? Another equation here. Let's say let P equal A plus B. Let me call this equation star, star. And I say Q equal what? A minus B. Let me call this equation star, star. Are we together? If I want to know the value of A, if I have the two equations together, I'll have that A is equal to P plus Q all over 2. And if I take the difference between these two, I will have that what? B is equal to P minus Q over 2. Just like that. So anywhere we see A now, we can put this there. And anywhere we see B, we can put this there. So let's quickly use that to rewrite this particular equation here. So I will have, instead of AB, I will have it to be what? Cos P plus cos of what? Cos of Q. That will give me what? 2 cos into bracket P plus Q over 2. Then I will have what? Cos into bracket P minus Q over 2. So we reduce what? The sum to become what? A product. So we are done with the first one like that. So the second one, which is this, if I have cos of P minus cos of Q, this will result to negative 2 sine P plus Q over 2, then sine P minus Q over 2. So we can see that we'll go to the third one. So the third one is this, sine of P plus sine of Q. This will give us 2 sine A, that's P plus Q over 2. Then cos B, that will be cos of P minus Q over 2. Like that. So now the last one, which we have sine P minus sine Q. This will give us what? 2 cos P plus Q over 2. Then sine B, sine of P minus Q over 2. So you need to look at this very well and see, so that you will know when and when to make use of each factor formula. Let's see if we can look at one example before we round up the third topic. Okay, we have example like sine. Okay, we are asked to express the following as a product of two trigonometric functions. Sine of 7x minus sine of 3x. Now, you know, this is sine and this is also sine. So you check the factors formula, which one can work. You will see that it is what? The last one. So this 7x is equivalent to the P, and this 3x is equivalent to the Q. Hence, for us to express it as a product, we are going to have it to be 2 cos into brackets 7x plus 3x divided by 2, then multiplied by sine of 7x minus 3x all over 2, like this. So we then have that sine 7x minus sine 3x equal 2 cos. This plus this will give us what? 8. 8 divided by 2. So that was going to give, sorry. This plus this will give us what? 10x. So 10x divided by 2, that's 5x. Sine this 7x minus 3x, that will give us 4x. Okay, 4x divided by 2, so that will give us what? 2x. So it's as simple as this. So we then have in general that sine 7x minus sine 3x is the same thing as saying 2 cos 5x sine 2x. So here is it, the result. So we have expressed this difference as what? As a product. Do we understand this? Okay, so that is how we continue solving question on this. And this will mark the end of what? The end of trigonometry class, pre-calculus class to be precise, though later we are going to be making lectures on every other aspect of trigonometry aside from that one we need in calculus. So this will be the end of the class today. In our next class, we are going to start by looking at the coordinate geometry, which is another aspect of pre-calculus class. Thank you for watching, and don't forget to subscribe to this channel. Share this video with your colleagues. Thanks always. I really appreciate you guys. Have a nice day.